Hey guys, I've been getting a few questions on some of your study plan questions, so I figured I'd put them in a video in case anybody else wanted to see them too. So the first question I keep getting is under the 5.1, use composition functions to find unknown values in functions under the practice, and it is this question. So it says, let f of x equal ax plus b, g of x equals bx plus a, where a and b are integers, so that means they are whole numbers, positive or negative or zero, but they are definitely not fractions or decimals. If f of 1 equals 6, and f of g of 16 minus g of f of 16 equals 10, find the product of a and b. So in the end, we are left to find a and b, and then we have to multiply them together. All right, so based off what they've given us, I wrote it down. Let's get started. All right, so first we know this is f of x, we know this is g of x, and we know this. F of 1 is 6. So that means when I plug 1 into function f, so that'll be a times 1 plus b, when I plug 1 into function f, I know that a 6 is going to come out. So a times 1 is a, so a plus b equals 6. So we're left with this equation that we're probably going to be able to use at some point to help us find out what a and b are. That's some type of relationship that we know about a and b right now. The other clue they've given us to go off of is the fact that f of g of 16 minus g of f of 16 equals 10. So let's work with this now. Let's find these compositions. So this is going to be f of g of 16. G of 16 means plug 16 into g. So if I plug 16 into g, that's going to be 16 times b, which is 16b, and then plus a. All right, that's g of 16 minus g of f of 16. F of 16 means plug 16 into f. So if I plug 16 into f, that's going to be a times 16, which is 16a, and then there's still the plus b. And then this still equals 10. So now I have to plug this expression into f. So if I do that, f of 16b plus a, I'm plugging it in right there. That'll be a times 16b plus a, right? And then there's still a plus b on the end of that. And then I'm going to subtract all of this. Now I have to plug 16a plus b into function g. So now I have to plug 16a plus b right there. So that's going to be b times 16a plus b, and then there's still a plus a, and then it still equals 10. All right, well, we got stuff everywhere. So let's start cleaning all this up. So let's distribute. I'm going to get 16ab plus a squared plus b. Then I'm going to end up subtracting all of this. So let's clean this up. Let's distribute b. I'm going to get 16ab plus b squared. I still have a plus a on the end, and it still equals 10. All right, now I'm going to distribute my negative. So now I'm going to get 16ab plus a squared plus b. Now I'm going to get minus 16ab minus b squared and minus a equals 10. All right, well, right away, I can't help but notice that 16ab and negative 16ab, they're going to cancel out. No, nothing else cancels, but let's rearrange it in a better order, like descending, so in alphabetical. So a squared, then I'm going to get minus b squared, and then I'm going to get my minus a, and then my plus b that's left, and it still equals 10. So it's kind of like you've hit a wall. What else could you possibly do? So now you're kind of looking for ways just that you could manipulate the problem. So right away, I noticed this a squared minus b squared. Guys, a squared minus b squared is going to, that's the difference of two squares, right? So that's going to factor to a factor of a plus b times a minus b, which you can kind of see where I'm heading when things that are common already to the problem. All right, then I'm actually going to factor out a negative. So pull out the negative, and that's going to leave me with a minus b, right? If I put the negative back in, equals 10. So what I've done just by pure manipulation, Zach, can you let the dog out, please? By pure manipulation is I've created a common factor between this term and this term. Both of these have a common factor of, let me just move my camera a little bit. Both of these have a common factor of a minus b now. So if I factor out a factor of a minus b, that's going to leave me with a factor of a plus b, right? And then minus 1. That's what I would take. I would have minus 1 left if I took a factor of a minus b out. and that equals 10. So now, whether you leave this in parentheses or not doesn't actually matter, because now we already know what a plus b is equal to. We already know that a plus b is equal to 6. So I can plug that in right there. So now I'm left with a minus b
Mommy,
times. Yes.
He doesn't want to go out.
Okay, but he was scratching at the door. Please let him out.
No,
All right, so.
I don't want to go out with him. Do I have to go out?
So, no, you do not. So now a plus b is actually 6 minus 1 equals 10. Well, 6 minus 1 is 5 equals 10. So now instead of distributing, I'm going to divide the 5 away to get rid of it. And you're going to be left with, I'm running out of space here, a minus b equals 2. So now I have another equation with a relationship of a and b. So now I have a minus b equals 2. Well, guys, I already know that a plus b is 6. So let's use that to kind of create a system. Just let him out. It's fine. Please turn the light on. So a plus b equals 6. A minus b equals 2. And now I can use your system to add them together. A plus a is 2a. The b's will cancel, and it equals 8. And now divide both sides by 2, and a is 4. And then if a is 4, b must be 2, right? If I plug 4 in, all right, leave them be. So now a is 4. So if a is 4, b must be 2. So now that I know what a and b are, now the problem asks me to find their product. So a times b is equal to 4 times 2, and that equals 8. So at the end of the day, a times b is 8. Okay, so again, that's a little tricky just because of all the manipulations they expect you to be able to do, okay? But that's how that problem works. And then the other question I was seeing coming through was, which one? Same category. This one. So it's still under the 5.1, use composite functions to find unknown values in functions. So this one says f of x equals 4x squared plus 3, and g of x equals 2x plus a. Find a so that the graph of f of g crosses the y-axis at 403. Okay? Okay. All right, so if we do this one, first of all, let me get my pad up. Hold on. All right. All right, so f of g of x crosses the y-axis at 403. Well, first of all, what does that mean? It means that when you plug 0 into the composition function, 403 is going to come out. Because if you cross the y-axis at 403, that's a y-intercept. And we know a y-intercept is the point where x is 0 and y has some value, in this case 403. So that means when you plug 0 into the composition function, 403 has to come out. So let's find the composition function. What is f of g of x, right? So that would be f of g of x is 2x plus a. All right, so let's plug 2x plus a into f. So that's going to be 4 times 2x plus a squared, and then we still have a plus 3. So now I know when I plug 0 into this function for x, 403 is going to come out. So let's plug 0 in for x now. So 4 times 2 times 0 plus a squared plus 3, 403 better come out, right? All right, so 2 times 0 is 0, 0 plus a is a squared is a, times 4, that's 4a squared, plus 3 equals 403. Let's minus 3. That leaves us with 4a squared equaling 400. Let's divide both sides by 4. That leaves me with a squared equaling 100. And now the square root of both sides I find out that A equals plus or minus 10. So A could be positive 10 or A could be negative 10 to make this equation true, to make sure that the composition function crosses the y-axis at a value of 403. So now I believe in here they ask you to use commas to separate values. So you would just put 10 comma negative 10 and don't use spaces. All right? All right, perfect. I think there was one more. Let me just see if I can find it. All right, guys. The other question must have been from a homework that someone was asking me, and it's a good one to kind of go over because I feel like I had to go over this kind of quickly in class. So just about finding inverses. So here's a function. It's the function f of x equals x squared plus 2. So again, without this restricted domain, that would be the graph of a parabola, which we know would not be 1-to-1, so his inverse would not exist. So they've restricted the domain so that his inverse can exist, right? So the first thing I like to do is let me get a picture of this. So however you want to think about this, if this is vertex form where it would be x minus 0 quantity squared plus 2, so your vertex is 0, 2, or whether you want to do negative b over 2a and get x is 0 and then plug it in and get a y of 2. Either way, this is definitely a parabola that has a vertex at 0, 2. And then I'm going to use 1a, 3a, 5a, my pattern to graph the rest of it. However, I'm only allowed to plug x values in that are less than or equal to 0. So you're only creating that left side. So it would be left one up 1a since a is 1, left one up 3a, which is 3 since a is 1, and then so on. And that would be the graph of the original function. So right now he has the ordered pair 0, 2, the point negative 1, 3, the point negative 2, what is that? 5, 1, 2, 3, 4, 5, 6. Okay. All right. So we know that that's the original function. It's definitely 1-to-1. So if I want to find the inverse, not only are the x's and y's going to switch on the graph of the inverse, they're also going to switch in the equation. So the equation says y equals x squared plus 2, right? So let's switch x and y. X equals y squared plus 2. I'm going to minus 2, and then I'm going to get x minus 2 equals y squared as I'm resolving for y to get the explicit form of the inverse. Remember, this is the inverse, but is the implicit version, and we want to resolve it for y, so we have the explicit version of the inverse. Square root this side. When I take the square root of a square, it's going to create two versions of this, so plus or minus the square root of x minus 2. So guys, this is the inverse, but remember, technically, obviously, I hope you know, this is not a function. When you plug a number in, you're going to get two different numbers out. We're not going to keep the plus or minus sign. You're just not sure which one you need to make the inverse true. So I would say pick a point off the original, like 6, negative 2, right? If negative 2, 6 is on the original, then 6, negative 2 has to be on the inverse. So I have to be able to plug 6 into the inverse and get a negative 2 to come out. So if I plug a 6 in, 6 minus 2 is 4. The square root of 4 is 2. But I want the negative version of that because I need a negative 2 to come out. So in this case, I want to keep the negative sign as part of my inverse. So the inverse is going to be y equals the opposite or the negative square root of x minus 2. And then that will make all of this true in reverse. So the inverse is f inverse of x equals the opposite of the square root of x minus 2. So that's definitely your inverse. Now, if they asked you to graph it, just switch all the ordered pairs. 0, 2, 2, 0, right? Negative 1, 3, 3, negative 1, right? And then 6, negative 2 is going to be, I keep saying it backwards already. Negative 2, 6 is 6, negative 2. And now the inverse looks like that, right? It looks like you've taken this and reflected it over the line y equals x. All right, so what if they asked you for the domain and range? Well, we already know the domain of the original is x is less than or equal to 0. The range, if you look at his graph, is when y is greater than or equal to 2. So as long as you know the original's domain and range, you know automatically then the domain and range of the inverse. This domain is the inverse's range. This range is the inverse's domain. So the domain of your inverse, well, if his y's are greater than or equal to 2, then his x's will be greater than or equal to 2. And that makes sense because we want to keep the numbers under this radical positive. That means they'd have to be numbers that are greater than or equal to 2. And then this one's range is this one's domain. So if his x's had to be less than or equal to 0, then this one's y's have to be less than or equal to 0. And guys, look at the y values that are going to live on this graph. They go from 0 all the way to negative infinity. All right. All right, perfect. I just wanted to go over that again. And if anybody has any other questions, please feel free to reach out to me.